Okay, the next thing I'm going to talk about is secure coding concepts. And really what we're talking about here is application development and the balancing act between time to market and security. If you're in development or if you've been around developers, you know it's always, quick, quick, quick. We have to get there immediately. The first person to the dance, so to speak, wins, right? The time to market, speed to market is imperative for either a differentiation or some type of competitive advantage. So when we're building applications and we're coding for these types of things, security often will take kind of a back seat. All right, it's viewed as a necessary evil, right? So it adds to development time and ultimately reduces or increases, I should say, that time to market. So it's critical, though, to really kind of keep this in perspective. If we don't have time to find the vulnerabilities, then the bad guys will. All right, so if you don't have time to do it right the first time, how are you going to have time to go back and redo it? Perhaps a second or a third or a fourth time. Not to mention the lack in consumer confidence or the damage to the company, loss of data, et cetera, et cetera. So application development and that coding is critical. And there are a couple concepts that we need to be aware of, all right? And that is the concept of error and exception handling. So when we write our code, when we write the applications, all right, and I don't necessarily expect you to be a developer at this point, but you need to have a security mindset. And you need to, when you're interacting with developers, when you're interacting with management, when you're interacting with other areas within your company, you always have to have that security mindset in play. Okay, it's critical that we approach things this way because not everybody thinks with a security mindset, right? As I mentioned, sometimes, or a lot of times actually, depending upon the company, security takes a back seat. Right? It never fails. They see the security guy walking down the hallway and everybody kind of scatters and goes the opposite direction. They don't want to necessarily hear the buzzkill coming in saying, oh, guys, we need to lock this down. We need to lock that down. Are you looking at this and looking at that? You have to just make sure that we communicate with everybody with the mindset of, are you testing? Are you understanding how the application fails? Because it will fail no matter how well it's written, no matter how good the programming is. At some point in time, given enough time, hackers, if they sit there and bang away all day at it, will find some way or some method to get into that application. So the error and exception handling is, what does the application do when it encounters an error? Does it continue running? Does it restart a process or a module, or does it completely crash? And really, depending upon the attacker's motives, they may want to simply get in it and get access to a website. They may want to crash it completely to see if they can get some type of elevated privilege, right? And get into the kind of a backdoor into that system, which may then lead them into other systems within your environment. We want to code and make sure that we're gracefully erroring out so that when we pass an error, we don't give too much information to the attacker or to the end user. We simply say an error as encountered and not something that you see on the right-hand side where it gives us all this information as to what may have happened, because that just gives an attacker that much more information, right, to basically fingerprint that application and to fingerprint what's happening behind the scenes, all right? So ultimately, as I mentioned, we're giving keys to the castle if an application crashes and gives away too much information. So the other thing is input validation. So when we have a web form, let's just say, for instance, it is a web application, whether it's signing up for an email or whether it's signing up for a mailing list, or it could be actually checking out and putting in your information, your credit card, your mailing address, and so on and so forth. That input validation needs to be validated and it needs to be sanitized so that when it's entered, it doesn't necessarily, or it doesn't have the opportunity, I should say, for an attacker to put in malicious code and crash the system. All right, so it will mitigate such attacks as cross-site scripting, and we'll talk about that in just a moment, or SQL injection attacks. All right, now there are some applications you'll see on the right, Metasploit, ExploitMe, and there's some add-ons for Firefox, NetSparkler, and then of course all the ones I showed you within Kali Linux. There are a lot of tools out there that will allow both malicious and non-malicious, or white hat and black hat hackers, to basically go out and capitalize on those vulnerabilities. So input validation is critical. We have to sanitize that data before it gets passed on to the server. Okay, another thing with secure coding are two references I want to draw your attention to. One is OWASP or OWASP, and that's the Open Web Application Security Project. And you see the link here basically gives you some secure coding best practices and a quick reference guide. And then CERT also has one as well for secure coding. So I just want to bring your attention to those two references so you can go in and get some additional information if you are so inclined to read up on secure coding concepts in a little more detail.